Dear children, now you came to the most important lesson related to the competency level 2.3. So far you have learned about mixtures, solubility of the mixtures, methods of expressions of the composition, and learned different techniques that can be used to separate either solvents or solutes from different mixtures. Definitely, you must have a question. Why we should learn this stuff? What is the purpose? Where we can use? This third lesson and the 8th lessons tell you the application of them, or else the practical usage of the knowledge. Let's proceed. The extraction of salt from seawater. Now you can use the knowledge of different separation methods here. Now you know seawater is a homogeneous mixture. Different salts are dissolved in seawater. Now looking at this table, you can get an idea. Sodium chloride dissolved in grams. If you take 1 liter of seawater, there you can find 29.1 sodium chloride, 3.58 magnesium chloride, 2.34 magnesium sulfate, 1.44 calcium sulfate, 0.72 potassium chloride, 0.17 calcium carbonate, 0.05 magnesium bromide in a liter. So there you can understand high amount of sodium chloride dissolved in seawater, but other types of salts also in seawater. Now when you learn this lesson, you have to understand what are the points that you have to pay your attention. Here we expect that you should be able to point out the separation techniques that are being used in the salts industry. Normally the questions are formed to check whether you can point out the separation technique. So let's see the separating techniques on extraction salt from seawater in Sri Lanka. Can we make, you know that sea is a major source of salt. Sri Lanka is an island surrounded by Indian Ocean. That means plenty of seawater around our country. And I hope you have visited to Putlam or Hambantota saltons as your annual field trip. Those are called saltons. The question is, can we make saltons in any coastal area even though Sri Lanka is surrounded by an ocean? The answer is no. We cannot make a salton in Negombo area. We cannot make a salton in Colombo area even though they are coastal areas. So then, why? Because there are certain factors we have to consider when setting up a salton. Let's see what are these factors. The land should be situated closer to a sea or the coastal area or to a lagoon to obtain seawater easily, as seawater is the major source. And the soil of that selected area should be clay soil. Why? You know that clay soil having the particles of clay soils are close, very, very close, and they are fine particles. So the soil have the capacity, the soil does not let water to go through it. That means minimum percolation. කාන්දු වීම අතිශයින් අඩුයි මැටි පසක. Then the third factor is prevalence of dry and hot climate with bright sunlight and wind throughout the year. That is a must. An area with minimum rainfall. Prevalence of wind throughout the day, low relative humidity are the factors that we have to consider. If the land is located below the sea level, so it is really easy to fill the tanks during high tides. Now, where we can find the saltons in Sri Lanka? Putlam, Hambantota and Elephant Pass. Putlam and Hambantota are the major saltons in Sri Lanka. Now let's see what are the techniques used in Sri Lanka. It's very simple. We use evaporation and crystallization. What do we evaporate? Water from the seawater. Mixture, salt mixed water. Then we have to let the solidify or crystallize the salt. Let's see what the process of a salton. If we consider the structure, there we can find three types of tanks in a salton. Large shallow tanks, then medium tanks and small tanks. To get an idea, I put a rough sketch of a diagram. Here, large tanks, then the medium-sized tanks and small tanks. Let's see how we can produce salts. This is the first step. As the first step, what we should do, we have to pump seawater or flood, let it to fill with seawater during the high tide period to the bigger shallow tanks. And we allow to evaporate by sunlight until the concentration double the initial concentration of seawater. That means the taste of salt is double as the seawater. At this point, calcium carbonate begins to crystallize and precipitate at the bottom of the first tank. Remember, this is not sodium chloride, calcium carbonate. Then what we should do, we have to remove the water in the first tank and transfer it into the medium-sized tank. There we allow further evaporation until the concentration comes 4 times higher than the initial tank. Again, we can observe a kind of precipitates or the crystallization. That is also not sodium chloride, it is calcium sulfate. Now what we should do, then the remaining solution allowed to flow to the small shallow tanks. Again we allow further evaporation until 10 times higher than the initial concentration. So at that time sodium chloride starts to crystallize. So now you can understand, while sodium chloride starts to crystallization, you know that further water get evaporated further. Then what will happen? Magnesium chloride and magnesium sulfate also starts to precipitate. Now in the tank, sodium chloride, magnesium chloride and magnesium sulfate, all 3 types of salts are in the crystallized form. The important thing is this magnesium chloride and magnesium sulfate, if it is mixed with sodium chloride, what will happen? Gives a bitter taste to the salt. Then you can understand, just think about here the salt, sodium chloride, magnesium sulfate here, upper the water or the solution. This solution is called as bittern or the mother liquor. So what we have to do, when the salt starts deposited in the third tank, we have to take them out and heaped in a prismatic piles. Here you can see it's like a prism. and we have to keep these heaps another 6 months. And also we have to cover it with coconut kachans also. Why? There is a reason. Because once we heap like this way, what will happen? There I have mentioned that magnesium chloride and magnesium sulfate also mixed with sodium chloride. This magnesium sulfate and magnesium chloride has an ability to absorb water in the atmosphere. Once they absorb water, what will happen? These magnesium chloride and magnesium sulfate comes to its liquid state and remove from this solid crystals. Remain only sodium chloride. Now we can, because sodium chloride won't absorb atmospheric moisture. That means hygroscopic, not hygroscopic. They remain as solid. Now we can get pure sodium chloride. Now we'll see the summary. 3 tanks. First tank, larger, shallow. When we put seawater, when the concentration double, calcium carbonate deposited. Then remove the water to the second tank, medium sized tank. There when the concentration comes to 4 times, then calcium sulfate starts to deposited. This remaining portion move to the flow to the third tank. There when the concentration comes to the 10 times larger than the initial concentration, sodium chloride and magnesium sulfate and magnesium chloride starts to crystallize. This is the summary of the process. Here this pictures also shows you the steps. If you have time, please watch these small video clips. Thereby you can get a better idea about the salt and salt industry in Sri Lanka. Those are very small clips, but this one is a documentary. It's a really nice documentary. Please see and vast your knowledge. Now we came to the end of the video clip. A special thank for Mr. G.D. Subhasinghe, retired science project officer in Sri Lanka, and thank you for watching this 7th video. Thank you. Please remember to put a comment and share the link with your friends.